Okay, starting off Unit 2 here. This is going to be about, this whole unit is perpendicular and parallel lines. So we've talked about those already. Perpendicular, we know, comes to form a right angle, right? This is not perpendicular. Straight up and down like that's perpendicular. Parallel, we know they never, ever cross, right? They're headed in the same direction. So we know those two words already. There's a new word in your vocab you're going to learn today, which is called skew. Skew lines are neither of these. They're not parallel and they're not perpendicular. If you want to think about this as like two planes that are flying over each other in different directions, they're not crossing, so they're not touching, so they're not perpendicular, right? They have to touch to be able to be perpendicular. But they're also not parallel, right? They're just flying over each other, but not going the same direction, right? This would be parallel. Skew is, again, not perpendicular, but not parallel. So we're going to see that in our pictures today. And then we're also going to be, again, practicing these new relationships that we did in class with the transversal and the lines crossing through it. So let's go ahead and look at example 1 in your notes for 2.1, very first lesson here. So what we're going to do here is identify if we have in this 3D figure parallel, perpendicular, or skew lines. So this is, again, a 3D figure of a cube. We know these dashed lines mean like they're the back side of the cube we can't see. So that's what we're looking at here. But again, this is a drawing of a cube. So let's look at what lines we're looking at here. We're looking at A, B, and DC. Find those in the picture real quick, and I'm going to highlight them. Well, here's AB, and here's DC. What we want to say is, are they parallel? Do they point the same direction? Are they perpendicular? Do they cross at a right angle? Or are they skew, which again means neither? What do we think looking at those, A, B, and DC? Those are going to be parallel because they are headed the same direction, right? Both A, B, and DC point on the sides of our cube there. Let's go ahead and erase that, and let's look at the next ones. EH and GH. So EH and GH, find those, and I'm going to hide them as well. EH is here, and GH is here. So notice they touch, they share H, right? They're coming together in that corner. So what do we think? Parallel, perpendicular, or skew based on our definitions? This is going to be perpendicular because they're crossing, since this is a cube, cubes have right angles all the way around them, right? They're not slanted. They're just straight up and down. That's going to be a right angle. Even though it's not indicated in the picture, if they tell us this is a cube, yeah, we're going to have right angles there. So this is going to be, again, perpendicular. And let's try the last one. So we have FG and CD. Once again, find those in the picture and see where they are at. I'm going to highlight them in just a second. Here's FG and here's CD. So notice they're not touching, right? CD is going up top and FG is kind of going backwards like this. Based on our definitions, what do we think? Parallel, perpendicular, or skew? This is an example of skew lines. Skew kind of means like messed up. If you were to say something is askew, it's all jumbled up, like my desk in my classroom is askew often. So they're kind of jumbled up, right? They're not pointing the same direction, but they're also not touching. These are called skew lines. So we'll practice that more in class. We just want a real quick introduction to those definitions. What I want to do from here is we're going to keep going to example 3 now. We're going to do 3, 4, 5, and 6. This is just practicing those new terms we talked about in class. So again, look at example 3. So we are talking about corresponding angles here. Now you probably don't see this in your packet because your packet's in black and white, but 1 and 5 are red. That's because these are corresponding angles. They might look a little bit darker in your picture possibly. So that is one example of corresponding angles because they are in the same position in each x, right? If I'm looking at this x and this x, oops, 1 and 5 are both in the top left corner. So I want you to name one other pair of corresponding angles besides 1 and 5. Again, think about the circle. Are they in the same position in the circle? 1 and 5 are both top left. Name another pair. So you could have said 2 and 6. These are corresponding because they are both top right. Again, here's 1x, 2x, angle 6 and angle 2. Those are in the same position, top right. Or we could have said angle 4 and angle 8. Those are both bottom right. Here's angle 4 and angle 8. Notice I'm shading in the same part of the circle. Or you could have said 3 and 7. Those are both bottom left. So these are, I only said to list one, but these are all examples of corresponding angles in the same position. They correspond to each other. Okay, number 4, so we're looking at alternate exterior. So 1 and 8 are given to you as an example of alternate exterior because here's my river and here's my banks. Both 1 and 8 are on the outside because they're on the banks of the river, and they're on opposite sides, right? 1's on this side of the bridge, the 8's on this side of the bridge. So these are alternate on opposite sides of the bridge. Exterior, outside the river, right? So there is one other pair here of alternate exterior angles. What's the other pair here of alternate exterior angles? This is going to be angle 2 and angle 7. They are alternate because they're on different sides of my bridge, and exterior because they're outside the river. Let's try alternate interior. So once again, 3 and 6 are already given to you as an example of alternate interior. Interior now, because they're inside the river, right? They're in between my two lines. Alternate on different sides of the bridge. So what's the other pair of alternate interior angles? That's got to be angle 4 and angle 5. Those are on different sides of the bridge. That's alternate. But they're on the inside of the river. That's interior. And let's try the last one here. So the last one, again, is consecutive interior. I just kind of crossed it out. Consecutive interior. Consecutive, again, means now same side of the bridge. So 3 and 5 are given to you as an example of consecutive interior angles because they're both on the same side of the bridge, and they're also both in the river. To be interior or exterior, they either both have to be inside or both have to be outside. So what is the other pair of consecutive, meaning same side of the bridge, interior, meaning inside the river? What is our other pair here? That's going to be angle 4 and angle 6. They are both to the right of the bridge, but they are inside the river. Consecutive, same side of the bridge, interior, inside the river. So we're going to practice this again a bit more in class. As always, we're going to do the rest of the notes together in class. This lesson is really about just identifying these things, starting out pretty basic.